Good morning to everybody on the East Coast and the West Coast, and whatever time of day it is. I hope things are going well for all of you in our new abnormal. This is Judah Phillips. I'm the CEO and co-CEO and co-founder of Squark. And today we're going to talk about marketing predictive analytics and machine learning. And we're going to start by going through a little bit about Squark, and then we're going to jump very quickly into some core use cases that we believe are very relevant to marketing, show the data, the results, and conclude. So let's get started. Here's our agenda for today. I want to talk a little bit about what's going on, right? Our post-COVID-19 paradigm for marketers, and how that can be impacted positively by technology like Squark. We're going to talk about what data is needed, and we're going to go through 7 use cases that cross the marketing life cycle, starting with conversion, going through attribution, segmentation, price prediction, promotional prediction, lifetime value prediction, and churn prediction. And kind of stepping through the key actions one might want to take when managing, customer relationships in marketing. So the post-COVID-19 paradigm, like lots have changed. Where I am outside of Boston, wherever you are located in the world, we're certainly not in our offices anymore. We're not able to hang out with our friends and family as much as we'd like to, unless we're not socially distancing with our immediate family. Fundamentally, we're not being able to go out to have meetings or our offices, to restaurants for dinner. Our social behaviors have completely changed. The way we check and understand facts has changed. Our priorities, right, have completely shifted from perhaps being more work-oriented to more protecting the family-oriented. Many of us, unfortunately, have gone through trials and tribulations with our jobs, whether it's based on being laid off or furloughed, or maybe your job has been enlarged and you're having to do more with less. I've talked to many marketers whose hiring has been frozen, or whose teams have been furloughed, and they may not be getting any analytics anymore. Clearly, the economy across the world has been negatively impacted, and there's a ton of volatility within the stock market, and obviously that's impacting sales life cycles and closing rates. Our purchasing habits have changed. We may be buying more in bulk. We may be buying items that are related to other items. I'm sure many of you are out there trying to find things like disinfecting wipes, and they're not available in many countries. What's the alternative? What might I suggest? And related to all of this, our buying processes have changed. I don't know about you, but I've been buying things more in bulk recently. But a lot of things haven't changed, right? Life goes on, hopefully. But our needs for food haven't changed. Healthcare has become more important. Upskilling, becoming more educated. How we entertain ourselves. Various other things I've listed here haven't changed, right? And as a result, we believe that, in the past, insights were great for storytelling. It was fine to look into, the descriptive past and diagnose what's happened. But today, Squark believes that, insights, however valuable, sometimes are latent and delayed and can be hard to apply within this new paradigm. Thus, actions that you can take out of your marketing data will replace insights. And if you've ever seen our advertising on various channels, we talk a lot about how actions beat insights. What we've noticed over the years with the traditional predictive analytics and machine learning processes is that they take a long time for people. They require expensive resources. There is a latency in the deliverability. Most data scientists have less than 3 years experience and cost upwards of $130,000 in the US, and you still have to arm them with hardware and software to do the job and wait. And how does a manager, how does a business person validate the work of a PhD in an esoteric field? Within the analytics world, there's often delivery of data on time, timely, and sometimes late. And we've seen a lot of late delivery of data science projects. As a result, one of our Fortune 100 customers has done some research and indicates that only 13% of of predictive models actually make it into production. So by and large, and this I'm sure is an inflammatory statement, data science has failed most companies and really isn't working out very well. It's complex, it's expensive, it's too hard to do. It requires esoteric resources that are limited. So we disrupt that. We go all the way around that. We've created a capability that allows for non-technical business users who understand their data, have data dexterity, maybe usernames and passwords to MarTech systems, or who can make requests to their analytics teams or get the data themselves to not only find insights that are predictive, but to take action with those insights. This is some data from Gartner, maturity models, right? There's a lot of maturity models. I've built a few in my books, the analytics value chain, so on and so forth. This one, I think is so simple, it makes a lot of sense to people, especially those who haven't been steeped in analytics over the last 2 or 3 decades. Most companies today do descriptive and diagnostic analytics, especially in marketing. The idea that you get business questions, you understand requirements in business questions, you instrument your marketing systems to collect data. You come up with KPIs that you believe to be leading or lagging indicators of marketing performance. You visualize them, and you describe things that have happened, and you do diagnostic analytics. You tell stories, and storytelling is super important, right? It strikes a certain core vein in the human consciousness to understand stories. But if you're just telling stories about the past and hoping that your parable applies to the future, at Squark we think you're missing something. You're missing the insights about what will happen and how can you make things happen in the future. So we like to think that Squark moves companies up the curve from descriptive and diagnostic analytics into a predictive pattern that's repeatable, affordable, easy to sustain, and dramatically moves the business forward. Actions beat insights. So predictive marketing actions, what are these? These are things like reducing churn, personalizing. We're going to go through a bunch of these in a second. Attributions, recommendations, forecasting lifetime value, doing, ad hoc marketing mix analysis without having to spend hundreds of thousands of dollars with an agency. Squark, fundamentally puts a moat around your MarTech stack. I know there's 8,000 MarTech stacks. We believe we're the one that actually does this in full glory, and we've received the validation of Forrester as the only automation-focused predictive marketing analytics, a predictive machine learning platform that focuses on marketing. So we can operate in the full MarTech stack, whether it's Google, Domo, Microsoft, Salesforce. We have services-based connectors that we can work with you with to bring in this data, and we expect to be expanding a lot of connectors as well as data distributors into the future. The idea being that most marketing analysts have access to data in these systems, and they have usernames and passwords. They can extract CSVs or spreadsheets. The most popular, analytical tool for analysts tends to be Excel, regardless of all the evolution in the power of marketing capabilities. And like I said, most analysts can access data in these tools. What Squark does is we have 4 model classes in the tool. I'm going to demonstrate 3 of them today. The 4th one is not in our freemium version, but which I'm using to do this demo today. So there's this idea of binary classification, right? That's kind of a very technical term. What that means is, which 2 things are going to occur in the future. So for example, will an ad get a click? Will the customer convert? Will the customer churn, right? Will the MQL be won or lost? Will the journey result in a conversion? These are binary outcomes that can be modeled with binary classification. We also do multi-class classification. And that's where we're trying to predict across 3 or more outcomes. For example, you might have 12 different segments historically, and you want to learn from those segments and apply automatically a segment name to new customers. Or say you're sending out offers and you've sent 10 offers and you've gotten some response. Now you want to know, well, what offer should I send to new customers, and what's the probability of those other 9 offers to be responded to by those customers? Or perhaps you want to understand what's driving outcomes, right? So for personalization or for targeting. So multi-class or multinomial classification can help answer those questions. We also do regression, which many of you probably remember from college or business school, where fundamentally we're predicting a value, right? Continuous value in the next period. So answering the question of how much will occur, and this can apply to pricing, to lifetime value calculations, even to forecasting. But of course, our regression does do things like factor dates. We have quite an impressive array of feature engineering in the product. We don't consider regression to be true time series where we're focused on, auto regression or seasonality. So in more premium versions of Squark, we can not only tell you how much will happen, but how much will happen across n time periods. Perhaps you're a marketing executive trying to forecast marketing costs across the next several days for your paid media campaigns, or you're working with your sales and your account executives and you're looking to project potential revenue across the next 12 weeks or 365 days, or really any metric, right, that you have associated with time. We can learn from that data and forecast into the future automatically. And all of these use a series of different algorithms, whether they're trees or ensembles or gradients or general linear models, deep learners. We've baked that in. Obviously with time series, we use things like ARIMA and SARIMA models. So if you can put your data into, or your questions on your data into, this type of rubric, which 2 things will occur, which 3 or more things will occur, how much will occur in the next period, or how much will occur across time, Squark can help you. Here's what Squark does behind the scenes. We connect sources, we authenticate in, we have a learning process, and we do automated data preparation. We don't consider ourselves to have purchased Paxata or Trifacta, right? Our data detailing actually involves improving the training data to advance the accuracy and the predictive value of our models through a preparation and a potential enrichment step in more premium versions, as well as things called feature engineering. So we may bin and flatten, encode, or transform data. We may, in the case where there's differences within the class distributions, you have more wins than losses. We can upsample, meaning we can create fake data that's never existed that meets the statistical distributions of one of those classes, and add new data to your data that allows us to potentially improve predictive power. Some algorithms don't like missing values, so you impute them, right? Others think missing values are okay. Our feature engineering might bin data or flatten data, right? So you have a column of job titles. Well, it's great to know a job title is an important feature for predicting a win. Wouldn't it be great if you knew which job titles, right? Which companies, which industries? Feature engineering allows us to create many different versions of the training data that you upload for Squark to learn from, and appropriately adjust them and tune them to maximize the predictive value within the algorithms and the model instances on those algorithms that we iterate through. Squark, the models we create, it's not a static model. They're dynamic models. We may create thousands of models within the time period you allow us to run, validating and cross-validating against a holdout sample of known outcomes to understand the accuracy of our models and the generalizability in production environments. We do an automatic optimal model selection. It's a full scoring pipeline without any of the hassle of worrying about all the technology that underlies. Completely disruptive in that we go completely around that, up towards the business, focus on the use cases, get the ROI, and move on and watch our customers become even more successful than they've been in the past with their marketing analytics. And then we create the predictions. So we score data right within the same spreadsheet you upload, or the training data set that you, or the production data set that you upload that we learn from. And then we have the capability of exporting the data to integrate it into other systems for automation. And we have existing model explanation capabilities in some of our more premium versions. They start with variables of importance and go through things like partial dependency plots and so on and so forth, if you're familiar with things like K-Lime and Gainslift plots. And our goal obviously is to allow marketers to take action, right, by pumping that data back into systems and visualizing it. If you're a Domo user, I believe we're one of the only companies that's allowed to take data from Domo, run it in our in Squark, and return the predictions and the rest of the results back to Domo for using their awesome capability for BI and data visualization. Connect, learn, model, act, right? Actions beat insights. So what Squark does, it's kind of where we're coming from. Our idea when me and my co-founder started the company was to democratize data science. It's a little cliche to say that today, though I still hear it. But the idea being that things like Google Analytics, are so easy to use for digital or web analytics. But back in the day, in the late 90s, early 2000s, when I was doing web analytics, we'd be indexing log files, using things like rsync to move log files around. There were no spider and bots lists. It was a little harder to do web analytics. Now just get a tag, throw it on, and boom, you've got better and a dimensional model, drill up, drill down, filtering, segmentation, connection to other systems than we would have had 20 years ago. BI, for example, 15 years ago, hire a bunch of engineers, DBAs, come in, conceptually model your data, logically model it, physically implement it. No one would believe the data in the database match the data in the reports. Now everybody doesn't question, that works. And you get something like Domo, and you're up and running within hours with richer, more fulminant capabilities than you would have had 15 years ago with some of the companies that still exist today. We noticed that AI and machine learning just simply hadn't gone through that paradigm shift. So, we wanted to ensure that, that would occur, right? That machine learning and AI could be democratized such that people who may not have learned to code, may not understand the underlying algorithms, could still get out sufficiently accurate and business valuable predictions that move their business forward in a quick and nimble way that allows for action, right, without latency. So your CMO, your boss, knows what's going to happen before it happens, and you do before your competitors do. We abstract all this into Click. It's a no-code system, right? And we've made some, automations and decisions that we know work in a generalizable way. And a goal is to augment humans. It's not to replace anybody. It's not to replace data scientists. We have some of the world's best data scientists using this capability. Why? Makes them agile, makes them faster, allows them to outsource some of the lower hanging fruit so they can concentrate on some of the harder work that takes longer and is necessary to have a PhD to do. Then for folks who don't have data scientists, small businesses, the mid-market, super corporate, we provide a capability that is differentiated and yields outcomes that you can action very quickly. So with that said, let's take a look at what happens. We get record level predictions, like things like lead 356 is 79.23% likely to convert, and lead 357 is only 57.87% likely to convert, right? Which one do we talk to first, right? Obviously higher converters, right? Let's talk to first. We have metrics and KPIs to confirm validity. These can be a bit esoteric, but they can certainly help understand the performance of the models. In the freemium version, we give you a peek of the variables of importance. So, which data is most influential. And I want to show you how that appeals to attribution algorithmically in a very important and I think groundbreaking way. And obviously we can integrate for deployment into other systems. Yes, it is a white box. You can audit the underlying code that's written as well as see the explainability. But of course, like many things in machine learning, some algorithms are a little more opaque, right? deep learners, more opaque than trees. So what data is needed to do all of this? It is supervised machine learning. Yes, Squark has capabilities for unsupervised machine learning, particularly on the Domo platform. We'll see those integrated at some point in the future. But the data that's needed is historic data that has known outcomes, right? Supervised machine learning learns from labeled data, and it learns the patterns and the relationships within that labeled data. For example, you have a customer record, all your customers who have churned. We learn from that churn label, and we can predict on new data. There are attributes of that data, and those are the columns. Those are called features in machine learning parlance. So we have a known label, we have a feature space, and we learn within that feature space on how to predict for that label. In sort of normal business school parlance, you pick a dependent variable, right? Your target column with your label, and you pick which predictor columns or independent variables you want to use. ML picked up the scent. And we have an automated process where you actually upload predictive production data that has unknown outcomes with the same feature space. Obviously, if you haven't learned on a particular feature, you can't score on it. And we put within the same spreadsheet those new predictions on that new data from our learning. If you want to use new features, exclude features, Squark allows you to do that, relearn the learning process. And we get these predictions with probable outcomes on a one-to-one basis. Here's an example of binary training data. This is real data from a telecom provider. It's masked to some degree. But you can see this is the fundamental canonical format that Squark ingests, or company like Domo ingests, right? You have columns and rows. Everybody can understand columns and rows. Each column, each row in this case is a customer. So this is customer 7590. She's a female, not a senior citizen, bought our telecom service at a partner, does not have dependence on it, has been a customer for 1 month, does not have phone service, has DSL, online backup is present in her record, but other attributes or features of their telecom service are not, such as streaming movies or streaming TVs. We have a little bit of information about how she's paid, what method she uses, how much she's paid in her per month, and how much in her lifetime of being a customer for 1 month. And we have a label here. In this case, it's 0 or 1. The label could be yes or no, right? It really doesn't matter what the label is as long as it's binary. It could be sun, moon, right? This is an example of training data. We learn from this, in this case, to build a churn model, or actually with Squark, any label in here could be used for prediction. In one file, I could predict total charges. I could predict with multinomial which contract type to offer new customers, the likelihood of customers to respond to streaming movies, right? So on and so forth. Again, multiclass, right? As I just described, can be modeled within the same file, and regression can also be modeled within the same file by simply selecting a different column. We have customers that are running hundreds of millions of rows, hundreds of columns. I've seen feature engineering expand to thousands and thousands of columns. So we've solved the scale problem. I've even seen customers run 189 records. One of a pharmacy school actually received models that were more predictive when cross-validated than the pharmacy college adaptive test in about 15 minutes. So this stuff works, and it's disruptive and changes the paradigm of how you can think about and do marketing analytics. What production data is, so there's two things you upload in Squark. There's that training data you learn from and the production data you want to score. We automatically hold out 20 or 30% of the training data. We don't look at it, and when we do cross-validation and k-folds cross-validation, we score that holdout sample to determine how accurate each model is as we iterate and checkpoint, and then we surface the model that is most predictive for your data. We use early stopping, back propagation, things like that. Logarithmic loss for binary, if there's any data scientists on here. Class error for multi-class or multinomial. Deviance for regression. And RMSE and MAE for our time series stuff. So 2 files are required to run this: the historic data with your known labels, and that data that has the same feature space, new data haven't seen before that we want to add predictions into. So let's take a look at what this, let's dive deep. Let's take a look at what this looks like for sample marketing use cases. We're going to go through those 7 use cases now. Predicting conversion. Who doesn't want to predict conversion, right? Maybe you're a large company that uses Pardot, and you're required to call every lead that comes in through Pardot before it goes to Salesforce for AEs as a marketing qualified lead. But wouldn't it be great if you could learn from all the successes you've had with your contacts and reprioritize your call center's list to call only those, or call first those contacts that are likely to become MQLs? And wouldn't it be cool if, now that you knew that they were MQLs, you could figure out if they were SQLs, sales accepted leads, wins, predict their ACV or their sales? But you can do that with Squark. And I want to show you a simple way to do that within the traditional marketing and sales funnel. This is Salesforce data. It's super masked, but it's real data. We love Salesforce. We love HubSpot. Neither one of those companies do what we do. And I'm happy to explain why in the questions. And in this case, we've got, a whole bunch of columns and customer records. Some of this data is sparse, right? It's missing values. And we know whether these leads have converted or not. So we want to learn from this past Salesforce MQL data and predict, for new Salesforce MQLs, who is going to win. We simply run the case, and we come up with models like this. When I first saw these AUCs coming back, I said, there's got to be some leaky data. I went to our engineers and the really smart people behind the scenes that are building this stuff. And it's real data. There's no leaky data in this. We just happen to figure out how to do this really well for Salesforce and other CRM data. Notice, even with the hype of deep learners, maybe using deep learners for binary classification doesn't work as well as some of these other models. We do confusion matrices, both binary and multinomial, where we can show you the results of the cross-validation. We end up with something related to the models called variable importance. So in that large Salesforce training data set, there were a number of columns, right? All the way to AQ, right? So more than 30 columns. But our feature selection, at least with the gradient boosting machine, reduce the columns to the particular ones that are not correlated with the others, and we provide a variable of importance indicator. There's been a meme in analytics for a long time. Data doesn't tell you why, it only tells you what. Been doing this for a long time, and I've worked with market researchers and qualitative researchers. That's always been wrong. Qualitative research can tell you why, and machine learning can start to hint at why as well. So as a result, we end up with a file that we've uploaded, the production file for the leads that we like to score whether they win or not. And we end up with a distribution at the end, right? You can see that these ones here are predicted wins, and we show you how predictive the wins are. This data was very well suited for this type of learning. Let me show you another example. This is algorithmic attribution. I've written some books on this stuff. I've worked in a lot of companies that have done this stuff. Last click, first click, engagement mapping, there's been so many different models over the years, weighted, decayed, equal. Algorithmic attribution is pretty cool. It's just been really hard to pull off. And fundamentally, when you take data like this, again, this is real data, this is cookies, and then we mask this a bit, right? Imagine these were the touches, right? These are actually which marketing tags were on various sites. And whether, exposure to those marketing campaigns and those tags resulted in a conversion. So imagine you're going across, a set of ad campaigns, whether it's path to purchase or, customer journey, and you're getting exposed to these touches. And whether those exposures occurred, and whether those cookies or those known visitors converted. Well, we can learn from data like this, and you can see this is probably, 200, 300 different types of marketing tags. and we build a model. And this one, again, machine learning is not magic dust. The AUC on this model is about 0.73, right? The traditional way to understand this, though there's a lot of debate about this, is if it's above a 0.5 AUC, there's some predictive power that goes beyond guessing. Some people will say, well, AUC isn't that important, right? You got to look at other things like business value. We get that. We're cool with that too. And we have these coefficients that come back. What this data is kind of telling me is that those journeys that are most likely to convert tend to see Adobe Marketing Cloud, Omniture Site Catalyst, Adobe GTM. Google Publisher Tag isn't present. So we give you the coefficients as well as the variables of importance. In this case, this is general linear model coefficients, which you can create odds on, right? Long odds. So quite simply, if you have marketing touches and those touches have occurred or not, and that those touches for each cookie or each person result in a conversion or not, you just simply upload that data to Squark, and we build the algorithmic attribution in minutes over and over again as your data changes. And what's kind of cool about it, not only do we get the algorithmic attribution, similar to the conversion example I showed you, we'll also tell you which customers in that journey, right, are likely to convert. So we give you the attribution and the conversion, which is very different. And there's not a team doing this. This is all dynamic and automated, and you're doing it at a much lower cost than building an algorithmic attribution model from any agency you'll ever find. So example 3, predictive customer segmentation. So wouldn't it be cool if you kind of could just predict which customers should be served in a certain way, like put them automatically into a segment? This can also apply to cross-sell and upsell, right? Where people, you don't want to use collaborative filtering or some other rules. You want to kind of go outside that paradigm. You can predictively segment with Squark. This is more of a multi-class example. So this is real data from a retailer that you probably have all shopped at. The family is one of the wealthiest families in America. And what we're trying to figure out here is, can we learn from UPC's actual products, right, that have been purchased, both returns, department descriptions, other fine line, category numbers, and the number of visits that a person makes to predict a particular trip type. And these trip types are encoded, right? But I'll explain a little bit more. Are these grocery shoppers? Are these school shoppers? Are these weekly shoppers? Are these monthly shoppers? Are these Christmas shoppers, right? When, what do I send them for a flyer? How might I personalize a kiosk if I knew these people were walking in a near field environment? This type of automatic segmentation or predictive segmentation is very straightforward to do with Squark. It's a multi-class challenge, right? So we look at mean class error. It would be very hard for a human to take a look at this data and, with a low error rate, predict which segment a person might be in. And you get your variables of importance. We know things like the visit number, the find my number, how many scans, particular department descriptions are driving, this type of retail or e-commerce segmentation. And we get predictive customer segmentation. So for new data, we can say, hey, we've learned from the past and all the segments that we've identified from the learning, and we know that when Judah walks into the store, he's segment number 26. When John walks in, he's segment number 37. When Chris walks in, he's segment number 38. When Dan walks in, he's segment number 8. When Dennis walks in, he's segment number 999. And you can see the probability of a user to be in the other segments as well. So if you start to think of cross-sell and upsell opportunities across segments, that becomes impossible as well with Squark. I want to show you another example. So this is like predictive offer targeting. This is data about customers, their kind of brand affinity, the categories, their average order value, the campaigns they've been exposed to, demographic information, their age range, whether they're married or not, do they rent, how big's their family size, what's their income, what discounts have they used in the past for coupons, when do they shop, what day, week, the number of items they've purchased. And then there's a coupon that we know that these people have responded to. So can we learn from this information to suggest a coupon or an offer for new data that meets this feature space? And the answer is we can. And so we do a model, and again, this one was a small data set. So I said, engineers, guys, I'm seeing like zeros here. This is pretty interesting. But if you start to look, as things iterate, the machine is getting smarter. I mean, XGBoost is just a powerful algorithm. Again, we see that feature space has been collapsed as well as engineered, right? So in the sense, we can tell you not only that campaign type 0 is more predictive for a particular coupon, AOV is very important for the particular coupon and the brand that people like. You probably saw maybe 15 or 20 columns there. Well, not only have we engineered more columns, but we've reduced that feature engineering through feature selection. And you can do campaign, ad, and offer predictions. So now I know that I should send coupon 7 to John, coupon 3 to Chris, coupon 6 to Dennis, coupon 9 to Dan, coupon 11 to Pablo. And I can see the probability of those coupons, the other coupons being responded to within Squark, right? So again, you're moving from descriptive, maybe I can figure it out with KPIs and lagging and leading indicators. And maybe I need to buy, multiple tools to do that, and it doesn't actually happen in my promotion offer system. To a system like Squark, where, bam, we're doing it on the fly, nimbly and flexibly, as your data changes, as your needs change, as your coupons change, as your campaigns change. And, business users are doing this. We have one client that's seen a 4% increase in revenue response for donations on $5 billion in donations. Now, that being said, not all of our campaigns are deployed. Their campaigns are deployed through Squark, but for those that they see a 4% increase in campaign performance on a 12% reduction in marketing costs, which for this company is hundreds of millions of dollars a year. So the ROI is real. Let's do another example. So this is price prediction based on product features. I was going to do a whole bunch of price prediction today. And, my team saw some of this stuff, and I pulled it out because, I started to get into some really esoteric use cases around choice data and, user attribute selection. And I wanted something really easy for you guys to see. Here's another cool data set. Anybody ever use Airbnb, or other hotel, hotels? Well, this is that type of data. We have a customer with an ID, a type of property, a room type, whether there's automatic cleaning, what city it's in, various attributes about the amenities and the description, the name of the different properties. And Squark's got natural language processing capabilities, right? We can extract, the most frequently occurring synonyms. They become new feature vectors. So we can process not only structured data like you see here, but when you have unstructured data and strings within, we can pull not only that information out into new features, but we can use it for prediction. And so in this case, we want to say, all right, we have this inventory of properties that we want to price effectively for our customers. How do we do that if we're Airbnb? Well, what we can do is we can take, Squark, and we can use it, and we can learn from this data. And we can come up with a model like this. Again, this is more of a regression. This is a regression model. We rank our leaderboard on deviance. And you can see the mean average error is about $8 or so. And we find out that what's really important to pricing is, the room type. This is an engineered feature, the entire home or the apartment, how many bathrooms it has, what type of accommodations, where is it, right? Is it a private or a shared room? Particular cities that tend to have impact on pricing. So you kind of, again, understand why some of the decisioning is occurring. And as you start to peek into other X.AI or model explainability capabilities, this type of information gets much more richer and transparent. And you get predictions, so personalized pricing. Now I can suggest to a hotelier or a room owner, an apartment owner, here's our suggested price, right, for your property, learning from what's been successful in the past. If you're Hilton, if you're Marriott, right, this type of predictive pricing is extremely powerful. Let's do example 6. We want to predict customer lifetime value. This is a regression example. We're going to go back to Salesforce data. This is Salesforce data, but in this case, these are, you know, customers, and they have a lifetime value. Can I learn from the lifetime value and the relationships related to those customers to predict the lifetime value? Not customer profitability, but, you know, a predictive, true measure of lifetime value. You can, right? In this case, we're looking at a regression model again with an MAE of about 2. With a mean deviance of about 7, and it's a stacked ensemble. We can see things like the recent deal amount is really important to lifetime value. Pretty obvious. The cool thing is maybe you just want to exclude that in a new run of Squark, you know, and see how that cascades into the models. And we see particular companies. Donetta Riccardi doesn't exist in real life, so or John Paletto doesn't either, or maybe they do, but this is all masked data, you know, with different labels that we've added to kind of confuse it. In terms of protecting the guilty. So what we've got here are the variables of importance that are most important in predicting lifetime value. You can see that, you know, oh, maybe we should talk to Genome Interclick or Zenith Optimedia in the UK, right? Send Donetta after them. And the predictive CLV forecasting in Squark for new data allows us to predict what might the lifetime value be for these new customers. Example 7, and this is going to be the final example for today, is predicting customer churn. This is kind of the default machine learning example, right? This is binary classification. Again, going to that training data I showed you initially before we got into these use cases, we have a label, and it's not a 0 or 1 this time, it's a yes or a no. It's that same data set. When I run it through Squark, we end up, you know, getting a model that performs about 70% greater than guessing. And we find out that the month-to-month contract is the leading indicator of churn. If we say expose some of our more our partial dependency plots and some other XAI capabilities, we could tell you which tenure, which total charges, which monthly charges are statistically significant in contributing to churn. Again, you know, coming up with why. And then you can do predictive churn prevention. You know, I know a few VPs of customer success at some awesome companies. I've heard through the grapevine that those teams and those executives sometimes have latent models that haven't been updated for months or years. And they're still asked every Monday morning to figure out, you know, who do I talk to this week to reduce my churn rate, to increase retention? Well, Squark's nimble and flexible enough that you can run it every Sunday, every Monday morning, and re-rank your churn based on what's actually happening in your business today with a custom created dynamic model that's applicable today, not dated in the past. And you can see here, you know, this customer 73% likely to churn, this customer 76% likely to churn. So, you know, what action would I take from that? Let's talk to the customers most likely to churn first, and let's not worry as much about those who are in the 90% unlikely to churn. Every Monday morning, the churn is known to that VP of customer success, and that team is reducing attrition in a different and better and disruptive way than has ever been possible in the past. So action beats insights, you know, connect, model, learn, model, and act. These are just a few of the use cases in marketing beyond what I've showed that we can execute very quickly for you, or I should say, you can execute very quickly for yourself as Squark doesn't require services. Got a bunch of customers. These are just some of our favorites. And we love them all. Those are the ones we can name. Transformative AutoML for new paradigms. We're proud to be covered by Forrester. Been in a few reports recently, and you can see us in the wave that came out last year. So that's the story, everybody. Thanks for bearing with me for the 45 minutes. I hope I didn't go too fast. I hope I was able to explain what Squark does, how we're different, how we're disruptive, the audience we're completely verticalized on, some core use cases that cross the marketing analytics lifecycle. And, you know, this stuff is real. It's not black box, though I understand those criticisms. It is transparent, it's explainable, it's integratable, and the coolest thing, it's actionable. It brings companies up that ladder of maturity from being purely descriptive and diagnostic, you know, reading the tea leaves in their dashboards and data visualizations and KPIs, to truly seeing not only hints as to why things occur, but also what actions, what insights are available, and what actions you should take next. So thanks for joining everybody today. I'll take a look at the questions, or maybe they're being fielded by the team, I would imagine. But of course, I'm Judah at Squark AI. If you guys have any questions, we have a freemium version, right? It limits the functionality. You're not going to get the full power, but it'll be free forever. And as you use it, we'll let you know when there's opportunities to improve and become a customer. So thanks, everybody. Looking forward to doing this again sometime. And thanks for your support and attending.